Hello everybody and welcome to your video notes on Learning Target 8.5 at the basic level, which is about parallel calculations. Should probably say parallel circuit calculations. So here we go. Should have watched part 1 before doing this and learned about series calculations. This is part 2, or designed to be part 2. Our goal is to fill out a table for a parallel circuit. Okay, I'm going to go ahead and put that table on the screen. All right, so we have a table like this, just like we had for series, and we'll have I'm going to go ahead and fix that. Okay, there we go, I fixed that. So over here we have our parallel circuit. You can see that this is a parallel circuit because there are all these resistors that are parallel to each other in the circuit, and there's more than one loop. Notice that we can have 1, 2, 3, 4 different loops. So that's why this is going to act much differently than we had for our series calculations. So it's gonna work very similarly, and these rules are only good for parallel. Okay, and you'll notice that they're going to be similar but different. So R is still easy. Fill it in. So here we are saying that R1 is 40 ohms, 2 is 50 ohms, 60 ohms, and 70 ohms. So I just got that from right here. Here's a major difference though. I is going to be different. This is because our different loops. I is different because there are different loops. And then V is the same. If there is one resistor in a loop. Because all of the voltage needs to be used up. Okay, so if we look over here, for R1, all 12 volts need to be used up going through R1 and going back to where it started from. So we have that loop, and then we have this loop, and all the voltage needs to get used up there. And then we have color. This loop, and then we have that loop. So in each of those loops, there's only one resistor. So we don't have to worry about using different voltages because all the voltage needs to get used up at each resistor. Okay. So now it comes to our table. We can't just add up our resistance this time, and I'll explain that here in a little bit. But since the voltage is the same for all of them, I can just have 12 volts here, and this is going to be the same for all of them. Okay, no calculation needed. However, the current, that's going to be different for each of them. But I already know two of the three things for each of them. I know resistance and I know voltage, so I can calculate this with Ohm's law. So here are the steps that we're going to follow. So first thing we need to do is, sorry about that, not sure what happened there. Let's keep going though. So our steps, I think is where I was at. Step 1, find the individual current using Ohm's law. And the second thing we'll do is we're going to find total current. And then the last thing we'll do, we'll find the total resistance with Ohm's law. Okay? So if we come over here, I'm going to zoom in a little bit. First thing we're going to do is use I equals V over R. We know that voltage is 12 volts divided by 40 ohms, and we get an answer of 0.3 amps. And then step 2, we'll do the same thing, but with 50 ohms, and we get 0.24 amps. So this one's 60 ohms, and we get 0.2 amps. Notice that the current is going down. The voltage is the same, but the resistance is going up. That's a relationship. As the resistance goes up, current goes down. Okay, so we've calculated all of this stuff. We've accomplished step 1. Now, we need to find the total current. To find the total current, you're just gonna add them up. Okay, so in the series ones, we added up the voltage. In the parallel circuits, we're going to add those up as well. So we're just going to add, and our total that we get is 0.91 amps. Okay, pretty easy. Step 2 is complete. And then we'll find our total with Ohm's law. Okay. So we know that I total is 0.91 amps. And we know that V total is 12 volts. So we've got our I equals V over R. If we rearrange that, we end up with R equals V over I. Okay. So let's just substitute and solve. So we end up with 12 volts divided by 0.91 amps, and we end up with 13.2 ohms. And that's it. We solved all of the different things. Notice that this is kind of interesting that 40 plus 50 plus 60 plus 70 does not equal 13.2. This is actually smaller than even the smallest individual resistance. That's why parallel circuits are used a lot. That we can put all of these resistors in parallel with each other and get less resistance. So here are a few takeaways. V total is always given. I total add up the individual I's, and the R total always be less than the less than the individual R's. All V's are the same. Okay? So these are some pretty important things. And you may notice at this point that it's going to be difficult to keep series and parallel separated. So here's what I'm going to do. Series versus parallel. Let's talk about what is similar but different. So in a series, I is the same. For parallel, I is different. For series, the I total is just I. And then for parallel, I total to add the I's. For series, voltage changes. For parallel, V is the same. For series, V total, add up V's. And then over here, V total is just V. And for series, R total add the R's. And then for parallel, R total is less than the individual R's. Here are things that are the same. There aren't a lot. You can always just fill in R and V total. You always do that first. And you also need Ohm's law. Or both. All right. That's all I got. I lied. Let's do one example. So I'm gonna just show you the answer to this here in a moment, but I want you to try to do this one on your own and then check your answer with me. Okay, here's what I got for my answers. So I started off just by recording my resistances. So I got my 8, 4, and 6. My total voltage was 12 volts, so I did that there. I was like, yeah, that's the same for all of them. So all of them were 12 volts. And then I calculated my I's. So I equals V over R, 1.5 amps, 1.5 amps, 3 amps, 3 amps, 2 amps, 2 amps. And in order to get that, I just added these all together. Just added, got my 6.5 amps So I got my total for my current, and then my resistance, my R total. I just used Ohm's law again and did 12 volts divided by 6.5 amps, and I got my final answer of 1.5 ohms, and I put that there. All right, thanks for listening.